Hello and welcome to this webinar with Cloud Academy on AIOps, the future of multi-cloud. I want to thank everyone for attending. This webinar is being recorded and we will have time for questions at the end of our discussion. We will also send a link to the recording to each of you very soon. Now I'd like to introduce everyone on the call. First, my name is Noam Bunder. I'm a content architect at Cloud Academy. We are also joined by Stuart Scott, our AWS content lead. We have Guy Hummel, our Azure and Google content lead, and we have Logan Rakai, our Labs content lead. I'd like to start out by defining what we mean by multi-cloud. It is a popular topic right now, but it can mean very different things. In RightScale's State of the Cloud report, which surveyed over 700 businesses, 84% described their organizations as multi-cloud. However, while many of these organizations said they were multi-cloud, they meant that they use both a public cloud and private cloud, or in a few cases, they use multiple private clouds. You should know for this webinar, we will focus on one specific multi-cloud model, and that is using multiple public cloud platforms, focusing specifically on market leaders AWS, Azure, and GCP. There are essentially four key approaches to multi-cloud. They include split cloud, multi-cloud DR, multi-cloud HA or high availability, and cost management or cloud arbitrage. The split cloud model is really the most common and simplest form of multi-cloud. This model uses one cloud platform to host an organization's test or dev environment, but another separate platform to run production workloads. Now, another take on this split cloud model would take a production environment and then simply split this production environment into multiple cloud platforms. Organizations will often do this to take advantage of services, features, or pricing that is available only in one specific platform or another. The multi-cloud DR model, or sometimes known as cloud disaster recovery, is a more recent and actually more complex multi-cloud approach. When you take this multi-cloud approach to DR, what you typically do is run your production apps in one cloud platform while maintaining a separate, up-to-date copy of those apps on another platform. Now, although these two approaches I just discussed, split cloud and the multi-cloud DR approaches both result in different workloads running on separate platforms, the operation or hosting of a single application across multiple cloud platforms result in what is essentially an active-active HA deployment of that app across these platforms. This type of solution protects those apps from things like DNS DDoS attacks, regional failures, and even failures of an entire cloud provider. This type of approach results in a recovery point objective, or RPO, that's theoretically zero in the case of a failure that affects one cloud platform. The least common model in practice is sometimes called the cost management approach, or cloud arbitrage. In this approach, an organization's workloads are dynamically placed on the cloud platform that has the most competitive infrastructure at the time of the deployment. This type of solution isn't the easiest to deploy, and there are often lots of challenges to making it work. Now, that being said, solutions like Kubernetes, as they improve, you will likely see more organizations try to leverage this approach in order to better manage costs. So now that we've gone over the approaches to multi-cloud, I would like to review the benefits of using multi-cloud. One of the most common reasons you hear from organizations is avoiding vendor lock-in. Most organizations want to be in a position where they can move to another cloud provider in the future if they want to. By using multiple clouds now, it is easier to architect your infrastructure so that you are not dependent on one particular cloud provider. To truly avoid vendor lock-in, you can elect to avoid vendor-specific services. So, for example, if you are using Amazon Aurora, that is a proprietary database, it will be more difficult for you to move to another cloud platform than if you were using, say, straight-up MySQL. Another example would be Amazon has two different container services. They have ECS, which is Elastic Container Service, and they have EKS, which is Elastic Kubernetes Service. Although if you use ECS, You can still move your containers to another platform. It will be a lot easier if you use EKS. So these are the kind of things you have to look at when you're trying to avoid vendor lock-in. But the trade-off with this approach is that it may not give you the full benefit of the platform. If you're avoiding these platform-specific services, you may actually be losing some of the benefits of that platform. Another benefit is pricing. Of course, when you have multiple vendors that all focus on different cloud services, it makes way for some competitive pricing between these vendors and across the platforms. Depending on which platform you're looking at, you'll see some have more of a range of a particular category. Let's say for compute services, for example, if one vendor had 15 compute services and the other had 5, the one with the additional services will have additional offerings, and they will have the capacity to implement a more varied and scaled approach. So the cost of those compute services, when compared, say, to the vendor with just 5. So that, with that in mind, you might be able to find a more cost-effective offering using a vendor with a more flexible cost plan. So having this freedom and flexibility of different public cloud offerings, you're easily able to leverage the most optimum and most cost-effective service for your required workload across all cloud providers instead of a single cloud provider. Another area is performance. Although this is not as commonly used as a reason for using multi-cloud these days, originally the idea was because each of the cloud providers had data centers in different locations, and you might want to have one cloud provider that just happens to have a data center near your office, let's say Sydney, Australia or something like that, and maybe another cloud provider didn't. Then you might want to have a multi-cloud model where the one that has the data center in Sydney, for example, you would put an application with that cloud provider for that particular part of the globe, and the people who would be accessing it from there with that application would have lower latency, and so they would get better performance and better responsiveness from that application. But I should say that all three of the providers have been adding data centers all over the place, and there aren't actually very many situations anymore where you would have one cloud provider that would have significantly better network response than another. For that matter, with data stored in different countries, you might have to comply with specific regulations and laws for data that differ. And if you're looking to use a provider that doesn't offer full compliance, then you could design the solution with a different vendor that does in that particular region. So you could also select a vendor based on its compliance programs that it has, and you could check out each of the vendor's websites. There's always a security compliance section, so you could find out all of the compliances they have, which they comply with, and this allows you to maintain your compliance for your different workloads that you might need to run. Using managed services that are fully compliant with specific regulations, for example, PCI DSS or HIPAA, is one thing, but operating that application and its data and maintaining that compliance is something totally different. So there's an annual review anew to ensure that you've maintained those compliances, and to help you do this, each vendor offers a range of services to help you manage your operational compliance across your infrastructure. For example, with AWS, you could use AWS Config to enforce specific rules that check the compliance of your resources against specific controls, and these rules can be predefined or they could be custom rules to match against what you need within your organization. Or you could use AWS CloudTrail, which is a service that records and tracks all AWS API requests made across your infrastructure. And these can be initiated from someone using an SDK, or the command line interface, the CLI, or from within the AWS Management Console, or even from a request made by another AWS service. So it becomes a really powerful auditing tool. So be sure to check out those kinds of tools across the vendors as well. I'd like to provide a quick review of the 3 public cloud platforms we are discussing and review what I feel are the strengths of each of the platforms. So starting with AWS, from a really high perspective, I'd say AWS is one of the most mature public cloud platforms with the broadest range of services, and the rate of innovation at AWS really astounds me. Month to month, year to year, it's really difficult to keep up with all the services being released and the rate of updates and enhancements to existing services, and this is really going to explode with the upcoming reInvent in December that I hope to see you at. So I'm expecting lots of new services, lots of new updates coming there. AWS is definitely a market leader within the infrastructure as a service space as well. Next, we could look at GCP. So when people look at the Google Cloud Platform, probably the most easily recognized strength of GCP is the AI and machine learning parts of it. Google has been really a pioneer in this area, and one of the obvious examples of this is they were the ones that came up with TensorFlow, and then they open sourced it. It's now been adopted by basically everybody, and it's the #1 machine learning framework out there. It's being used heavily on Azure and AWS as well. Google has been a pioneer in so many areas of machine learning. One example of this is they were the first provider to come out with their own specialized chips that were designed to speed up TensorFlow workflows. They have these chips that are called TPUs, which are Tensor Processing Units, and they came up with that significantly before anybody. So if you're looking at GCP, which is probably one of the reasons to be looking at them for that area, data analytics, artificial intelligence, machine learning, that's one of the areas where Google really shines. Google actually has a much greater incentive to make multi-cloud work because they're in third place in the market. AWS is first, and Azure is quickly catching up. GCP is quite a bit behind. Although they have quite a significant market share, it's not anywhere near where AWS and Azure are currently. So they have to come up with a strategy, and what they're doing is making it very easy for their customers to move between the different cloud platforms, because they want to take the customers who are already on AWS and Azure and bring GCP into their multi-cloud mix. So they've been doing things like they came up with Kubernetes. I already mentioned TensorFlow before in the AI part of things, and that was a very successful strategy because as long as people are writing things on TensorFlow, they could easily move from one cloud platform to another. They're doing the same thing with Kubernetes, where Kubernetes is a container orchestration system. It's a very sophisticated one because Google has been using it internally for a very long time, and they decided to open source it and make it available to everyone. And it has quickly taken over the industry, and now it's much easier to move containers between different cloud providers. So even though, in fact, AWS and Azure already had their own container management services that were proprietary, they both came out with managed Kubernetes services as well because there's been so much demand for it. So Google's strategy there seems to be working, and they keep moving with that. So they have another thing called Anthos, which is Kubernetes plus some additional tools on top of that. Just in general, Google is really big on open source. They have very big partnerships with open source companies, aside from coming out with their own open source tools. So if your organization is really strong with open source, then GCP would be a pretty reasonable choice for deploying these things to the cloud. And that brings us to Microsoft Azure, which really shines for organizations that are more heavily invested in the Microsoft ecosystem already. Programs and offerings like the enterprise agreements and the Azure hybrid benefit allow organizations to save money on cloud resources, while closer-knit integration options provide existing Microsoft customers with easier integration of on-premise solutions with cloud solutions. As far as the enterprise agreements go, if an organization already uses Microsoft software, they'll typically already have an enterprise agreement with Microsoft already in place. And what that does is it entitles that organization to obtain discounts on the Microsoft software that's being used. And this is because Microsoft will usually tweak these agreements to lower the pricing of Azure. So with enterprise agreements, you could typically obtain very significant incentives for using Azure. The Azure hybrid benefit is a specific pricing benefit for customers who have licenses with software assurance. So what this does is it allows organizations to maximize the value of their already existing Windows servers, SQL Server licensing investments, whenever they decide to migrate to Azure. Customers that are eligible for the Azure hybrid benefit can save up to 40% on Azure VMs, and even higher discounts of up to 55% on Azure SQL databases, SQL Server, on Azure VMs. So there's a significant cost advantage through the Azure hybrid benefit to go with an Azure solution. As far as integrations go, organizations that leverage Azure AD are typically able to get better integration with their on-prem AD environments with Azure using the Azure AD Connect software. What the Azure AD Connect software does is it enables the identity information that's stored in Azure AD to be consistent with whatever is stored in your on-prem AD. And with that tight integration that Azure offers, organizations can streamline user provisioning and user management. So we've discussed the strengths of the various platforms and the benefits of multi-cloud. But there is, of course, the other side of the coin there, and research also indicates that multi-cloud has its challenges, and largely this is a result of the increased complexity. The most obvious challenge is management. How do you manage all these resources and services in your different cloud platforms? So there are a lot of third-party tools for multi-cloud management, but even the three public cloud platforms do have some multi-cloud capabilities. For example, as we just mentioned, Azure AD Connect, the other providers have similar functions that allow you to synchronize your Active Directory with GCP and AWS as well. So actually you could look at that as being a multi-cloud management tool in the identity area. Some of the other areas are cost management. As I mentioned, there's lots of third-party tools for multi-cloud management. There are also in the cost management area. In this area, for example, I find it quite interesting that Azure Cost Management actually supports all three platforms. So you could, in theory, use that to manage your costs in all three. For monitoring, for example, Google has Stackdriver, which is the equivalent of AWS CloudWatch, and Stackdriver can actually monitor GCP and AWS resources. So that's at least two of them. As far as deployments go, with each of the platforms, they have their own deployment tools that work really well to automate deployments, like CloudFormation for AWS, Google Deployment Manager, and Azure has Azure Resource Manager templates. But if you want one that is cloud agnostic, that will deploy using all of these services, then you could use something like Terraform, which has plugins basically for all of these different services. So there are ways to do cross-platform deployment. If you use containers, it's a lot easier for handling things on multiple platforms. Docker containers, and Docker is definitely the standard for containers. If you use Docker containers, also if you use Kubernetes orchestration, then it's very easy for you to move applications from one cloud platform to another. So that's a good management tool in essence. The three main cloud providers aren't the only ones who brought Kubernetes in. You have companies like Red Hat. So Red Hat has OpenShift, which is based on Kubernetes, and VMware has PKS. So there's lots and lots of tools that are based on Kubernetes deployments, and that's a great way to handle management. As I mentioned earlier, Google has also come out with an open source offering called Anthos, which is Kubernetes plus Service Mesh and some other management tools, which make it even easier to move even really sophisticated applications using microservices from one place to another, even from on-prem to the different cloud providers. So they're launching lots of management tools out there, but frankly, it's still in the very early days of this, and there are really no clear leaders in terms of multi-cloud management. Now, looking at design and deployment, depending on your implementation of multi-cloud, for example, let's say you're using two or more public clouds to run the same application or service, perhaps for high availability. There's going to be some architectural and deployment challenges when you're doing it. So let's look at data, for example. If you're storing the same data across these clouds, then it can be difficult to maintain data consistency across multiple locations for that specific application or solution. You want to ensure all your data remains up to date across all the vendors, and this also adds a certain level of complexity. When you're trying to do search and retrieve specific data, and you want to do it in the most cost-effective and performant way. Not to mention that different vendors will be using different APIs, different security controls and authentication mechanisms and data formats. So there's a lot to consider when using multiple clouds when it comes to design and deployment. And I would say that kind of falls in line with management there as well. From a security perspective, I will highlight a couple points. There's going to be different security frameworks that each vendor is going to be using. So they're going to have to navigate each of those. And with that, we have ultimately, it expands the attack surface as well. And you're going to have to increase the amount of identity and access management, which manage your users and roles and groups. And you're going to have to understand the shared responsibility framework for each security vendor. And that's a key point. You really need to understand where your security boundaries start and finish between each cloud platform that you're going to be using. It might be slightly different between each platform, so make sure you have a solid understanding of that. You also might have existing tool sets, so do your existing security and monitoring tool sets work with additional partners to enable you to create a centralized and orchestrated security point? It becomes an ongoing development to implement security across multiple clouds, and it's one of the needs that you need to consistently and continually address, assess, and review regularly to ensure that you're not exposing yourself to any new vulnerabilities. So we've discussed security, deployment, and management in our discussion so far. It's clear that you need to understand not only what a particular cloud platform offers, but also understanding multiple third-party tools is going to be essential in terms of making use of multiple clouds and the solutions deployed on them. And clearly one of the issues of multi-cloud approaches is that it requires a wider area of expertise and wider technical knowledge. So we need to consider challenges that enterprise faces in hiring and training for multi-cloud environments. There's always going to be nuances between different vendors, so how do you configure and implement different cloud providers is going to change, and between each of the different services you're using, it's going to definitely require a broad and deep knowledge across each of these vendors. So you're going to have subject matter experts covering each vendor and different categories as well. For example, security, data, compute, machine learning, AI. So when you're going multi-cloud, it does require a considerable amount of effort from your team. You're unlikely to have a whole team of people who are up to speed on all three of the cloud vendors and all of the third-party management tools as well. So you might actually get a few people who have pretty decent knowledge of all of them, but they're probably going to be pretty rare, and frankly, you'll need a lead specialist in each of these areas. So from a hiring perspective, that's an issue. I mean, the people that you hire are not going to have all of the existing knowledge, but then every time the vendors announce all these new services that are coming out, all of the updates, people need to learn all these things. So there's a constant need for training. One of the things you have to consider if you have a multi-cloud solution, having one person trained in all three clouds, you can get that training, but at that point, if you don't use what you've learned, what good is the training? For example, if 2/3 of my organization runs on Azure and a third runs on AWS, and I'm the only guy on the staff that learns both technologies, both platforms, if 2/3 of my time is spent managing Azure resources all day, every day, and a third of my time is AWS, I'll tend to lose that knowledge. So it presents a challenge not only in terms of teaching the technologies, but how do you make up your team? Do you keep one person who knows everything, the jack of all trades? Do you hire multiple people, each with a focus on individual cloud providers with some background knowledge on the other platforms? There is no right or wrong way. It's going to be whatever is most beneficial for your business. Now let's take a look at the benefits of how artificial intelligence, AI, is intersecting the world of operations in multi-cloud and introduce a strategy for implementing AI ops in your organization. A wide range of AI abilities exist across all three cloud platforms, including everything from predictive analytics to natural language processing, which all can be applied to IT operations. These tools can be implemented to both automate ordinary human tasks, repetitive non-human tasks, as well as, most importantly, provide insight into operational patterns. The ultimate objective for an AIOps strategy is to guarantee data flows freely, is analyzed and processed, and based upon trained models, key patterns are identified and associated with automated workflows that can be kicked off, and the whole framework works in such a way that it learns and adapts to the changing data. Therefore, use cases need to be identified right off the bat. Each AIOps implementation needs to be scrutinized to the why of the desired results, its associated use cases prioritized, gaps identified between capacities, devices, skills, and processes. With time, technologies and needs are going to change, and new use cases will be presented. Appropriately, your ideal results will change, so your AIOps strategy needs to address these changes. First, you need to evaluate the ease and frequency with which your operational data in question flows, so you can get and send this information into the AI system. You need to have clear answers to questions like how and what sort of data do I get from my existing operational tools? How frequently would I be able to utilize this data and send it into my AI framework? Will I have the option to do so programmatically? When you have the relevant answers, you're going to be in a position to change your data consolidation strategy for your operational data and insert data streaming and analytics tools into your operational processes. Appraisal of that incoming data and data streaming abilities should be treated as a high-need task when you choose to build your AIOps strategy. Once you understand the data flows, you could use this insight to prepare AI and machine learning models to be trained to identify apparent patterns in the data that could indicate bad states, such as fraud, security risks, performance issues, or any range of operational insights in real time, and provide an automated response. Once AIOps frameworks are prepared with such trained models of key markers for these known bad states, you can be alerted and disregard the false positives. With time, you can define more and more automated actions to remediate and even forestall known and obscure issues. On our Cloud Academy platform, we have a range of courses on the latest AI frameworks and multi-cloud tools, which I encourage you to explore. Before we begin taking any questions, I do want to mention that Cloud Academy is designed to help organizations train IT departments. Cloud Academy offers courses, hands-on labs, and exams on AWS, Azure, Google Cloud Platform, as well as many cross-platform tools that we mentioned today, such as Terraform, Kubernetes, and TensorFlow, to name a few. Our training resources will help any organization prepare and stay up to date as it manages resources in the cloud. To review some of the AWS courses that we have on AIOps and MultiCloud, I introduce Stuart Scott, the head of our AWS content at Cloud Academy.
Thank you for the intro, Noam. So let me tell you a little about the content from an AWS perspective relating to multi-cloud and AIOps. So firstly, AWS has a series of services that enable you to create a hybrid cloud environment, linking your private cloud and your AWS infrastructure together across secure infrastructure, and effectively simplifying what can be complex peered networks. And in addition to this, there are various services to help you manage data transfer between multiple environments, and this allows you to get your data where you need it quickly and at scale. So let me just quickly highlight a few of these services for you. So from a connectivity perspective, we have VPNs, AWS Direct Connect, and AWS Transit Gateway. So VPNs, or virtual private networks, these are essentially a secure way of connecting two remote networks across the internet. And it's how many people create a multi-cloud environment today. For example, establishing a site-to-site VPN between an AWS VPC and then Azure's virtual network, the VNet. You can also create a VPN from your local data center to your AWS Virtual Private Cloud, your VPC. Now, VPN tunnels traverse the public internet, so Inherently, it's not the most secure method. So next we have Direct Connect. Now, Direct Connect doesn't use the public internet. Instead, it uses private and dedicated infrastructure which connects directly to your own data center, to your AWS VPC via an AWS partner managing Direct Connect infrastructure. And this provides a far more secure method than VPNs, in addition to offering greater throughput as well. Now, you can learn more about the networking elements of AWS in our course and lab content here, which covers more on VPNs and Direct Connect. Now, we also have the AWS Transit Gateway. Transit Gateway can be best described as a network transit hub or even as a regional router. It's a service that allows you to connect hundreds of VPCs and private clouds together. And you can also add Direct Connect into the system for more reliability and higher speeds when dealing with your private clouds. So with this kind of power, Transit Gateway allows you to create some incredibly complex systems. So in this course here, we look at how to connect these networks using the AWS Transit Gateway service. Now, moving on from network connectivity, there's a myriad of services that deal with the migration and management of data, which is crucial when working with a multi-cloud architecture. From a hybrid cloud perspective, the AWS Storage Gateway enables you to easily and securely connect your on-prem network to AWS, effectively extending your storage capabilities. And this is used to implement file shares, a low latency cache to access data, or indeed a backup service to replace your on-site tape libraries. With regards to getting your data in and out of AWS over the wire, again we have a series of different services and features, especially when trying to create a hybrid cloud environment between your private cloud and AWS. For example, we have AWS Data Sync, Amazon S3 Transfer Acceleration, AWS Snowcone, and Kinesis Data Firehose. Now, we have content covering all of these elements where we dive deeper into these services and features. Our courses we have are performing data transfers using AWS Data Sync. We have a lecture on transfer acceleration inside of using Amazon S3 bucket properties and management features to maintain data. Running operations and large-scale data transfer in non-AWS environments with the AWS Snow family. And an overview of Amazon Kinesis. Okay, so moving across to AI Ops, or Artificial Intelligence Operations. So AWS defines this as the process of using machine learning techniques to solve operational problems. And its main goal is to reduce the amount of human intervention in the operational processes. So from a content perspective, we have a wide range of AWS machine learning services and features covered. Many of them can be found in our AWS Machine Learning Specialty Certification, but I want to pull out a couple of learning paths that sit across this topic of AI Ops. Firstly, Introduction to Machine Learning on AWS. Now, this learning path provides an intro to many machine learning concepts with a blend of instructional courses, quizzes, and hands-on labs. You will learn how to implement ML services to create and use machine learning models and gain an understanding of deep learning and neural networks. And so by completing this learning path, you'll be able to recognize and explain the core concepts of machine learning, explain and apply distributed machine learning services, explain and apply supervised and unsupervised learning, classification and regression, algorithms, deep learning, and deep neural networks on AWS. The next piece I want to highlight is Start Modeling with Amazon SageMaker. If you're unfamiliar with SageMaker, then at its core, SageMaker is a fully managed service that provides the tools to build, train, and deploy machine learning models. So that's a very concise mission statement for what SageMaker can help you achieve. It has some components in it, such as being able to manage notebooks and helping label and train models, but at its core, SageMaker should be thought of as where you go when you need to build, train, and deploy models. So as a result, in this learning path, you will understand the key services of SageMaker, learn how to use training datasets with machine learning models in SageMaker, and understand how machine learning concepts can be applied to real-world scenarios. It also has some great labs in them too, for example, using SageMaker notebooks to train and deploy machine learning models, forecasting flight delays with SageMaker, and an Amazon SageMaker notebook playground. Also, we have the Beginner's Guide to Machine Learning and Artificial Intelligence, and applying machine learning and AI services on AWS. So across these, you'll be covering AWS services such as Amazon Recognition, Elastic MapReduce, Amazon Lex, and different machine learning and AI principles. Okay, so that was a quick high-level overview of some of the content we have in this area. So back to you, Noam. Thank you.
Thank you, Stuart. And to review some of our Azure and GCP courses on the topics of AI Ops and multi-cloud, I introduced Guy Hummel, head of our Azure and GCP content at Cloud Academy.
Microsoft offers lots of different AI services. If you're new to AI, then the best place to start is Azure Cognitive Services. This is a collection of pre-built artificial intelligence tools. These services let you add AI capabilities to applications, even if you don't know anything about machine learning. They're grouped into 5 categories: decision, language, speech, vision, and web search. For example, the vision category includes the Computer Vision API, which can classify images, and the Face API, which can detect faces in images. A related offering is Azure Bot Service, which gives you the tools to create a chatbot. This is an intelligent agent that can answer questions. For example, you could create a chatbot to handle simple support requests from customers. If you have some basic knowledge of machine learning, then you might want to try Azure Machine Learning Studio. It lets you train and deploy machine learning models without any coding, using a drag-and-drop interface. I highly recommend it for learning the basics of machine learning. A much more sophisticated option is Azure Machine Learning Services, which gives you full control over every stage of the machine learning process. You can use any Python-based machine learning framework, such as TensorFlow or PyTorch, train models using services such as Azure Databricks, and deploy models using services such as Azure Kubernetes Service. Azure Machine Learning Services is usually the best solution when you need to build your own custom artificial intelligence application. Google is known for being on the cutting edge of artificial intelligence and machine learning. For example, it shocked the world when its AlphaGo software defeated one of the best human players at the Go board game. If you don't have experience with machine learning, don't worry. Google offers lots of artificial intelligence services that don't require any knowledge of machine learning. At the moment, Google divides these services into 4 categories: Sight, Language, Conversation, and Structured Data. Under Sight, they have the Vision API, which detects objects, faces, and text in images, and the Video Intelligence API, which recognizes objects, places, and actions in videos. Under Language, they have the Translation API, which will be familiar to anyone who has used Google Translate to find out what something written in another language says. It supports over 100 languages. They also have the Natural Language API, which performs tasks like sentiment analysis. For example, it can classify a message as being positive, negative, or neutral. The Conversation category includes the text-to-speech and speech-to-text APIs, which do exactly what you'd expect based on their names. It also includes a groundbreaking AI service called Dialogflow, which is so good at sounding like a real person, it's almost scary. Using Dialogflow, you can build chatbots and voice bots to handle things like customer support requests. The last category is structured data. These services allow you to feed in structured data and get back insights. For example, Recommendations AI can look at a customer's previous purchases and recommend other products that the customer might be interested in buying. All of these pre-built AI services have been trained based on general sets of data, so they might not be able to handle your specific needs. For these scenarios, Google provides its AutoML suite of services. For example, you might need to identify product defects on the assembly lines in your factories. By feeding your own data into AutoML Vision, you can train a custom model without having to know machine learning. If you need to build custom models that are outside the scope of the AutoML suite, then you can use the AI Platform suite. It includes many services, but the most important ones are AI Platform Training and AI Platform Prediction. The training service lets you train custom models using popular Python-based frameworks, including TensorFlow, scikit-learn, and XGBoost. The prediction service will host your trained models and let you send requests for predictions. In machine learning terms, a prediction is basically the answer returned by the model for a given data record. For example, if you feed a new image into a trained model and ask what's contained in the image, the answer it gives is called a prediction because it's just making a very good guess.
Thank you, Guy. And to review some of the hands-on labs we have on Cloud Academy, which allow you to roll up your sleeves and dig into the technologies we have discussed around AI Ops, I introduced Logan Rakai, Head of Labs Content at Cloud Academy.
There is a lot of content in the Cloud Academy library to help you along your journey with AI Ops. I want to highlight some of the hands-on labs that will let you experience firsthand some of what can be involved with implementing AI Ops. Lab titles are organized by lab vendor on this slide. Starting with Google Cloud, analyze and retrieve information from text using Google Cloud Natural Language. In this lab, you'll perform entity extraction and understand how to perform sentiment analysis of text documents. Next up is visualizing trends from order history with Google Data Studio. This lab introduces you to Google Data Studio, which can combine data sources to make intelligent reports. Then we have structure and analyze data with Google BigQuery. This lab aims to help you understand BigQuery, Google's fully managed MultiCloud data warehouse service, including how to model data and perform queries. And the last one I will highlight for Google Cloud is drawing insights with BigQuery ML. This lab will show you how BigQuery ML extends BigQuery to train, evaluate, and predict using different machine learning models and visualized datasets. Moving on to Amazon Web Services, the first I'd like to highlight is collecting log data with Kinesis Agent and querying with Amazon Athena. In this lab, you will use Amazon Kinesis to stream log data from instances into Amazon S3 and query the data using Amazon Athena. Next up is aggregating data with Amazon Managed Streaming for Apache Kafka, or MSK. Kafka is a popular tool for building real-time streaming data pipelines and applications. In this lab, you will learn how to leverage Amazon's managed streaming service for Kafka to stream event data. After that is sessionizing clickstream data with Amazon Kinesis Data Analytics. This lab will give you practice with Kinesis Data Analytics, which is in general a useful tool for real-time log analysis. This lab uses clickstream data as its sample application. And the last one I'll recommend for AWS is using SageMaker notebooks to train and deploy machine learning models. Amazon SageMaker notebooks provide a fully managed environment for machine learning and data science development. In the lab, you will use Python to train models using SageMaker algorithms and deploy SageMaker endpoints for real-time inference. And lastly, the labs I want to highlight within our Azure library include building Azure ML pipelines using the Azure Machine Learning SDK. This lab aims to get you started with Azure ML pipelines using Azure Notebooks to build a pipeline that ingests data, trains a model, and deploys a web service. Next is tuning hyperparameters with Hyperdrive in Azure Machine Learning. This lab will have you use Azure's Hyperdrive to automatically optimize the parameters used for training a regression model. Then there is creating a classification model with AutoML in Azure Machine Learning Studio. In this lab, you will create a predictive classification model with Azure's automated machine learning service to quickly discover the optimal model for a dataset. And last but not least is the Azure Machine Learning Challenge. Challenges are where you can put your skills to the test and prove your ability to train and deploy model in this hands-on performance-based assessment. This is the only challenge that I've recommended in this list. However, there are other challenges available, including for the other vendors.
Thank you all for joining the session. Please note you will receive a link to the recording of the webinar shortly, and please be sure to fill out the survey and let us know how we did and what you'd like to see more of. Thank you, and we look forward to chatting with you again at our next webinar.